In the first part, I will introduce the basic function of our knowledge graph. A simple use case is given here to further illustrate the specific function. As you can see on the screen, the query subject as well as the target are given by the user. Change the subject and push the button now, and you will get a totally different answer. Our knowledge curve system can not only conduct knowledge reasoning, but also perform calculations based on known parameters and user inputs. Enter the key factors now to see the powerful computing function of our knowledge graph. In the second part, let's get a deeper insight into the internal structure of our knowledge graph. The domain-based knowledge graph that we use contains 3 different relations, including inheritance relation, compositional relation, and capability relation. Ontology reasoning is conducted based on this complete knowledge structure. When there are multiple components controlled simultaneously, the division of knowledge domains can efficiently improve the speed of inference. As for the calculation part, the formula is constructed in the form of ternary tree. Then the calculated value of the child node is returned by iteration to obtain the final result. So in this part, I'm going to introduce the implementation of our knowledge graphing AGV system to verify its feasibility. User can freely design the route that they want the AGV system to follow. The visualization of the reasoning process is shown in the lower part of this video. In the process of converting the graphical requirements into movement flow, knowledge graph sets boundary rules to keep the current system working within the rational scope. So after that, it keeps playing a part in driving this AGV system by providing knowledge support in parameter calculation, state machine generation, and code module invocation. As a result, the Lego car moves towards the specified direction that our user